Hey, so today we're going to go ahead and get started with how to write the equation for a linear function from a graph. So if you're looking at this graph here, just note that when we have a linear function, it's going to be written in slope-intercept form to give us the easiest equation that we can write. And it's going to be the y equals mx plus b that you're used to. So just keep in mind that the number that is in front of x represents your slope. That tells you how steep your line is, and also if it's positive or negative, which direction that line is headed, whether it's going uphill or downhill. And that's your rise over run. So if we have a graph and we're asked to write the equation for that graph, we need two things. We need the slope and we also need our y-intercept. Now, in this case, if I wanted to write the equation to represent this graph, I would look for first my y-intercept. That's my b value for my equation. Here's my y-axis, and here's my line. So where does that line cross the y-axis? Right here at the value 5. So I know my equation already is going to be of the form y equals something times x, and then it's going to be plus 5 because that's my y-intercept. Now I need to figure out what my rise over run is. Now in this particular case, I've went ahead and you can kind of see where some of the points are that are on there. But if there aren't any points on your line already, just look for where that line crosses at an even grid line in the corner of one of those unit boxes. That'll help you kind of put a point there. Let's say we choose this one that we can use to find our rise over run. So if I'm trying to figure out what distance and what direction we need to travel to get from this point to the next one on my line, any 2 points will do. Let's say we choose these two. To figure out my rise, I need to go up 3 units, and then I need to go across 2 units. So that's a rise of 3 and a run of 2, and that is going to form our slope. It just so happens that 3 over 2 is not a fraction that can be reduced. So we can just go ahead and write that as our slope, and we are done with that equation. Now, if that were a fraction that can be reduced, if 3 and 2 had any common factors, then you would want to go ahead and reduce that fraction. But in this case, that's as simple as it can get. Okay, now let's do just one more example. I've got another graph, and again we want to write the equation in slope-intercept form. So if you look at your y-intercept, where the graph crosses the y-axis, it's here at -1. So we know it's going to be y equals something times x for your slope, and then that our y-intercept is going to be -1 since it's -1. Now notice this one, if we're going from point to point, I'm going to be going down 2 units. So I'm going to call that a rise of -2, and then a run of 1 unit, since we only need to go across one spot to get to that next point. So since it's going downhill from left to right, that's how I can tell my slope is going to be a negative value. And if it's anything over 1, can just be expressed as a whole number. And I can just say that my equation is y equals -2x plus 1. I hope that helps you write your equations.